Sorry, good morning. So I forgot to switch on the mic. So, regarding the quiz that I wanted to remind, and the offline mode it will be in, and it will be here only in the classroom. Only a couple of students have they are not here on campus, so for them there will be online mode, but same question paper, and there will be you have to keep your microphone on, camera on, and you may be asked to show around anytime. Okay, so all those things will be there. So one to one, we will have 2 TAs for 2 students. Okay, so you understand. Okay, so we were studying the 2D elasticity problem. Okay, and so far we got the weak formulation. From there we try to derive the discretized, basically the equation. So from the continuous system we have to convert into discrete system. That's the whole idea. And equation, the weak formulation we have, where something like this. So integrate over the whole domain, and then you have del S W T, right? So we have that W is Ws Wy, so that's the vector basically we're talking about. And then we had D, then we have ds, then you have U, right? And D omega. So this is on your left hand side, and this is supposed to be equal to two things. One is the force itself. So we have the boundary forces. So you say P. So actually we wrote we have to write W, T, and T like this, right? T gamma over gamma. Yeah, and then plus omega, and then W, T, and here you have body force. Yeah. So basically Ku, what we get from here is basically some function T Ku is equal to the Wt. I mean, this is the weight. Then K. Sorry. F. So these all things, as we have been doing always, the idea is to convert the whole thing into W transpose K times U. You understand what is the meaning of that? Is equal to that. Where W, last time we wrote it as V, right? And this we wrote as D, like that, right? So fine, you get it as and hence you have K D equal to, where K is the stiffness matrix, and D is basically what we have been writing capital U. This is the same. So this is a displacement vector, and this is the force vector. Yeah. For the first term, we have worked out, and we know that any function like a w, this w are talking about a small w, is wx, wy, and that we wrote in terms of the nodal weightage. Yeah, so that's the n times, we wrote is a, we call it v, where n was, this is 2/1, right? So, and this one is has to be 2/n. We said 2/n or 2n. 2n. So we have n1, 0, 0, n2, n1, n2, 0, 0, n2, and so on, multiplied by w, x1, w. So this is the weightage basically. W y1, W x2, W y2, to W yxn, W yn. Yeah. So 2/2n, 2n/1. So 2/1. This we have done already. This is the repeat. Similarly, u, we write same way, ux, uy is equal to n, and then you have u, we call it d, and this is same way, this one, n is this, so n multiplied by d, d is ux1, uy1, ux2, uy2, uxn, uyn. So this is all repeat what we did last time. Yeah, and then and so on. Finally, we got the, let's say this is part 1 or left hand side. So left hand side, that we got right time, where the last time was Vt, and then we had B transpose B, then B, and then d omega, and then you have this guy. Yeah, where you know what is the meaning of V. So this is this we call is V. This is V basically, and where D, this is D. So last time we derived it this one. Yeah, we had that. Okay, where B is equal to, again, the stiffness matrix size will be what? What will be the size of this? Looking at any, like in general, we have n noded element. So degree of freedom per node is 2. So 2n by 2n size of K. Yeah. So what is the size of D for plane stress or plane strain problem? 2D we are talking about. 3/3. So this will be equal to psi u 3 by 2n, and this transpose of that. So this will be total. We are talking about 2n by 3. So you get 2n by 2n. Yeah. So V is 3 by 2n. So you remember del n1 over del x 0 del n1 over del y 0 del n1 over del y del n1 over del x. Then again you have to repeat the same thing for n2 now. So del n2 over del x 0 del n2 over del y 0 del n1 over n2 over del y del n2 over del x, and so on. So this is what. Okay. Rest is right hand side. If you write this one, which all things are given, and t may be given. Either it will be like do you have to calculate that every gamma? No, right? Why? So I will take it up here only. So this one, let me use different colors. So we already know how it looks like. This looks like this. N times V. Yeah. So this part will be equal to this gamma W. I will just write T bar V gamma has two parts. Will be gamma U, where U is given, W. So let's write like this. W T D gamma plus gamma Q, where Q is given, W T D gamma. Now where U is given, W, it will be 0. Right? So simply this this will be 0. Hence you this will be transpose of that. Transpose of that. Yeah. So this value is going to be 0. This one is 0 at gamma U. Right. So this terms goes away. Only you have this part. Yeah, and that you will write is equal to, and if you put this value here, that becomes N times V. So you have transpose of that. So V comes out. So you have V, which is a constant because they are coefficients. So V transpose, then gamma Q, and then you have N, right? M transpose of that, and then T D gamma. You get like this. Yeah. This V vector, which is this one we are talking about, that comes out. The way you see here, this is out, this is also out. So this is the one which gives you the force. This is nothing but a force vector. So V transpose, and this is a force vector due to surface traction. Yeah. The force coming from the surface. Any question? Okay. The looking at some faces looks like you not get what the meaning of the surface when I say surface traction. See this T is given here, right? So we give the forces on the surface. So from there, force vector will be constructed. The other one is where you are giving the body force. The body force will be defined on omega. This traction will be defined on gamma t. So you have to construct the force because of both of them. It is same as in heat transfer problem. You have a heat loss at the surface. So force vector will also has to take care of that also. Right? A force vector will also have the heat generated. So B here is a kind of heat generation. T here is like a heat loss. Okay. Again here since it is not about energy, so there is no loss kind of thing. This force is force. Yeah. So you don't say that there is some kind of loss here. It's just the gradient, a flux. So ultimately we're talking about the flux. Okay. Any questions so far? It's all right? Tell yes, no, don't understand. And at least you tell, I don't understand. Okay? That's fine. Okay? Then I know how to proceed or not. The second part, this. Yeah, so this is the first part. Second part, sorry, this is 1, 2, 3. Okay, so number 3 part, if you see, we take a W transpose B d omega. Okay, and this will be equal to, you put the values like that, and you will, this will over omega will be equal to, you put the value, so this of this, so Vt will go out, and then we have N transpose B. You have N which is coming to picture as you have in the 1 degree of freedom. It remains the same, only thing is N is not a scalar anymore, it is a vector. Yeah, where N means this is a matrix. N means this. Yeah. So this is the basic definition. From that we write further and we say that combine them. Combining them, we have 1 is equal to 2 plus 3, and hence we have starting from here. So this we simplified somewhere, right? So yeah, this one left hand side, right? So this we have V will be T, dt, d, d, d omega is equal to, then you have the first one, right? So this also we can write, this is equal to V T, where F, which is coming from because of the V. So you have Vt and T, sorry, gamma T, N, then transpose T V gamma plus V T N transpose gamma, not gamma, it will be omega, then B. Yeah? So this will be B and D omega. So this is the basic equation. Now do all the conversion, and finally we, since V is arbitrary, right? It has to be true for any W. So that's why this arbitrary. So this will be K is equal to, sorry, K times, oh, here we forgot something, here there will be T multiplied by D vector here. So see, arbitrary, so we get rid of this. So what we have finally is K E is equal to, we have F because of traction plus F because of quadrilateral. And now you solve it. That's it. Okay, any question? Okay. Now, only thing is now how to solve the problems. Meaning that you have to discretize into certain number of elements and types of elements. So all the things you have learned already. For example, if you know that triangular element. Okay. It's also called constant strain triangle. CS2. Yeah. In contrast to LST, which is linear strain triangle, that we will see later on. But this is the just three noded element, and constant strain triangle. Strain, as you know, is what? Del U over del X, del U over del Y. And if you remember from the heat transfer problem, Q is constant within it. Del T over del X is a constant within this one. Why? Because B is constant. B matrix, you get the constant one. So if you get B constant, that really means the strain is also constant. Hence, this is called constant strain triangle. Meaning that if you use this kind of thing, then a strain within this will be constant everywhere. So you understand that it's not a very good idea. Yeah. But in any case, now we will repeat 1, 2, 3, x1, y1, x2, y2, x3, y3, and you have a point here which is xy, and hence you have everything that you remember. E applies here also. Xy is equal to a over a1 over a, and you know what is the meaning of that. So in I in general, xy is equal to ai divided by. So you know that these are the area, right? This is 1, so this area inverse n1, value of n1, right? And this is 3, right? So this is n3 and this is 2. So this is n3, right? So this is how we have defined. The same way, same thing you can use it here to work to solve the problems. Yeah. However, of course the size will be different. Size of the stiffness matrix will be different. Earlier it used to be 3 by 3. Now it will be. Huh? 6 by 6. 2 degrees of freedom per node. So you have. So how will you decide? It depends on how will the u vector, or we call it d, will look like. Which will be have. So you have displacement here, ux1, uy1, displacement here, ux2, uy2, displacement here, ux3, uy3. So the displacement vector will have all the 6. And you know that ku equal to f. U is 6 by 1. F will be similar, right? You have f. You will have f, x1, f x2, and so on. Okay? So the force will also be the same way. So you have f x1, f y1. Force here, f x2, f y2. And similarly here also, f x3, fy3. These are the forces. So force also is 6 by 1. So K has to be 6 by 6. Okay. Once you know that, then you have to find out K. K is equal to B transpose D, B, d omega, which is equal to, you have to find out what is the value of B. That's it. Things you know already. It is it's not new. B we have defined already here. What you have to do? Del n1 over del x. You have to find it. So del n1 over del x will be equal to. So if n1, you know, for example, n1 is equal to. So first you can write 1 over 2 area of the triangle, then 1 xy, then 1 x2 y2, 1 x3 y3. You write like that, right? So del n1 over del x is equal to 1 over area of the triangle, and then you have 0, 1, 0, 1 x2 y2, 1 x3 y3, which is equal to 1 over 2a, and then y2 minus y3. So this you will write here. Does it have x, y in that? No. Hence, you get B matrix which is constant. So you will get this constant, this is constant to begin with, this is also constant. So you get K which is a constant. Basically. Well, K is constant, but what I mean is this really in this case will be B, T, D, B, and then d omega, which is equal to area. Okay. Only thing is you have to now compose B matrix, and B matrix is composed this way. That's it. How to compose this one is the same way you do for that we saw yesterday. So as far as forces are concerned, you have the n which is given, and then you know that if we have a triangle 1, 2, 3, and n1 will be 1 here and 0 here and 0. It's like a plane. It is something like, let's see, here you have 1 and here is a 0. So it is like you have a tent, for example. Yeah, you have a plane which is lying on this one and one side, and it is 1 here. So it goes like this. It's a plane, right? So that means n1 is 0 here. That means on this edge only n2 and n3 will vary. n1 will be 0. And how will it vary? n2 will be 1 here as far as this line is concerned. n2 will be 1 here and 0 here. So if this goes like this, a triangle. Right? Similarly, n3 will be 1 here and 0 here. It goes like this. Yeah. So that means that when on the boundary, when we are talking about f, we are finding f t is equal to n t, and we have the fraction t theta. Okay, so if traction is given here, you are going to integrate along the line, and n you may be writing like this, the way you are writing here. But as far as this line is concerned, this converts into a simple linear function, yeah, along which this varies. Meaning that on this line you can write n1 will be equal to 0, n2, let's say call it s, this direction, length is L from here to here, n2 you will write it as 1 minus s over L, and n3 is s over L. You can write like that. It's the same thing. And then you integrate. Okay? Then you convert t as a function of s, and then you integrate like that. Yeah. When we solve problem, it will be more clear. Today we will just formulate, and then we will solve problem. So this you can find out easily. Yeah. So that really means that, let us say you have a triangle like this, and you have a forces here like this. Let us say this is given by T naught, and this vector is perpendicular to this. Yeah, constant. Then what happens? That this is continuous system, and we have to convert it into a system which is located on these nodes only. Right? So what we will do? Yeah, from here to this L, then here it will be T naught L over 2, and here it will be T naught L over 2. That's it. That's how it will do. Same things what you have done earlier, it applies here also. Yeah. Or if it's a triangle, so let us say it's like this. So here also you can write, here the value will be less, here value will be more. Let's call at the end it's T naught. Okay, this one is T naught. So it is L from here to here. So this will be T naught half T naught L, 1/3 of that, and half T naught L, 2/3 of comes here. Yeah. Direction remains the same. Whichever direction it has to maintain the same direction. That's the only thing. Yeah. So it goes like this one. But finally, when you formulate x, y, you have to find out what is the component, because in x, y, you have to write x component or y component only. Yeah. Or you can also do that T naught itself, you find out what's the x component and then you do, but you will get the same thing. Okay. Now, the last part also, that's straightforward. You have to put n and you have to integrate. But the insight is again that let us say you have a force which is constant. So let's say V naught equal to V equal to V naught x, Vx naught, Vy naught, which is given. Let us say. Yes, this is a constant.
Still working.
Here it's constant.
Which
then what is value here?
Vinod Amera agrees. Vinod Amera agrees to supervisor Vinod Bhaskar Mamaji or Mr. Vinod Thakur skating teacher.
Hey Siri, bye.
Okay, nice talking with you.
Okay, so in this case, what happens? See, at this point, everywhere you are going to do is 1/3 multiplied by area, right? So here it will be 1/3 of this area. So basically, the finally the things that comes here is in this direction, you get Bx naught area of that divided by 3. This will be Bx By naught area divided by 3, and so on, right? Bx naught A, everywhere it will be the same, right? By naught A divided by 3. So it's constant, this will be equally distributed. Bx naught A divided by 3, By naught A. Yeah. So this is the insight. Don't be lost into equations, right? This is the physical meaning of that. Finally, we are working with what? Only 3 things. The stiffness matrix, which is like a spring, as you understand. Then displacement, it can be fixed, or you have to find out how much it is. And third is the force. There's no other things coming here. All others are like it also has mathematical relevance, because things are started with those working in mechanics, but earlier there was no boundary between mechanics and mathematics, so a lot of things developed that way. So when you say once you have the strong form, and after that, even if you don't understand the problem, you will be able to solve it as long as you understand mathematics. That's the thing. Hence, this course is taught by mathematics also, by civil engineers also, mechanical engineers also, electrical engineers also. Yeah. So problems are different, but the basic mathematics remains the same in all cases. Yeah. And also the way it is taught is also depends on the instructor background. Right? So for me, see, I have not gone into so much of nitty-gritty of mathematics. So we kept on as like an engineer that can understand. Any question? Okay, and once you have that, you can also do the rectangular elements. Everything remains the same. Only thing is, let us say you have 0, 0, 0, A, 0, A, B, 0, B. Then you can find out N1, N2. You remember, right? N1 XY will be equal to the way we did earlier.
What shape function?
Shape function. Yeah, shape function only. So typically what you do, you have these equation and these equation. So finally it will be, because this is originally here, it will be 1 minus x over a and 1 minus y over b and so on. Yeah. Okay, in one of the lectures earlier, I will point out probably later. So you write like this one, then n2 xy will be equal to, here this is 1, this is 2, this is 3, this is 4. So we have x over a, 1 minus y over b, n3 xy is equal to x over a and y over b, n4 xy is equal to 1 minus x over a. So, and then you do the usual thing as we have done here. Okay, so we are going fast forward now because I'm just reminding that now you can fit this there also now. You know the shape function, the rest you can do. Once you have that, then remember triangular element, the quadrilateral element. 1, 2, 3, 4. That we map to this isoparametric element. Yeah, and we will have xi and eta system. Here we have -1, -1. Here we have 1, -1, 1, 1, -1, 1. This is 1, 2, number 3, number 4. In one of the lectures, previous lectures, later on, as pointed by one of the students, that I simply wrote in this case. Okay, so N1, what I wrote was N1 xi eta, I just copied that 1 minus xi over 2 because width is 2, 1 minus eta right. This is wrong, okay? So please correct it. This is wrong because that time in flow basically what happens is here it is the start from 0. So you cannot write like that, okay? So when you find it, I was myself surprised how confidently I was writing. But this is the wrong, okay? So this is not correct. You can also see the equations, you see? So equation of this is what? Xi equal to 1. What is the equation of that? Eta equal to? So correct is n1 xi eta is equal to alpha, then xi minus 1 eta minus 1. That's the correct. Right? And then you put n1 minus 1 is equal to 1 is equal to alpha, and then 0 minus 1 right? That means alpha equal to yeah. Okay. This is not 0. This is minus 1. Right. Yeah. So we have alpha times 4, right? 4 alpha equal to 1, so alpha equal to 1 over 4. Hence, n1 xi eta is equal to 1 over 4 xi minus 1 eta minus 1. Yeah, so please correct that, okay? So similarly, n2 xi eta is equal to n2. What do you have? We have this equation and that equation. What is this one? This will be xi plus 1, right? And that remains eta minus 1. Beta, and here you put value n2, and this is xi equal to 1 minus 1 is equal to 1 is equal to beta. Xi equal to 1, so it becomes 2, and eta is equal to minus 1, so minus 2 is equal to 1, eta equal to minus 4. Yeah? So what we get here is n2 xi eta equal to minus 1 over 4 xi plus 1 eta minus 1. Yeah. Similarly, n3 xi eta is equal to, this will be xi plus 1 eta plus 1, and it will be 1. Right? Xi equal to minus 1 becomes 0. Xi equal to both 1, 4. So it should work. Yeah, and n4 xi eta equal to minus 1 over 4, and then xi minus 1 and eta plus 1. Okay. So put the value of 1 equal to 1, so becomes 0. Put value of eta equal to minus 1, becomes 0. And the minus 1, so minus 2 here. So, yeah, it's fine. So this is the correct one. Okay. All other things are fine there. Only this somehow it's not did not occur to me that here the origin is different now. Accordingly, you have to take care of that. And hence the writing as like equation, you see the two lines, that is better. That way don't make mistake. And also you catch me, you know. So this is that's the advantage of live classes where I'm making some mistake. A lot of things are corrected. Yeah. Because I come here and whatever I do here only, you know, so I don't have notes and nothing actually, and hardly see the book also. I come here and in front of you, whatever I have, I just do it. So once you have that, also doesn't matter. Then you have the equation, and you have to k, and here you have to k is equal to b transpose d b d omega. When you have that, then we have to compose b now, and remember this is in terms of xy coordinate. Now you have to convert to xy eta. The same drill you have to do, and b you have to compose now, where b is equal to as we did earlier, n1 dx 0 del n1 del y 0 del n1 del y del n1 del x and so on. So this you have to find out. And how will you find out these ones? By the relation. And what is the relation? Relation is del n1 del xi, right? Del n del over del eta is equal to, remember, you have the J matrix. So you have del x over del xi1, del y over del xi1, del x over not xi but eta, del y over del eta, and then you have del n1 over del x, del n1 over del y. Basically, this is true for all, and just in general, you can write like this: I, right? So if this is, you call it a Jacobian matrix J. So you get this by inverting this, multiplying with this. This you know because n is written in terms of that, and then you fill this value. That's what you do. Simple. So B you will get in terms of xi eta now, right? And there will be this J matrix as well. So all those things you know already, and based on that you have to transform that. So equation finally becomes the k will be equal to, now B you will get, which will be in form of xi eta now. So I'm writing xi eta, that really means that you have finally converted B in terms of xi eta now. That's what I mean. Okay, so you have that. Then B also you have in terms of xi eta now, right? And then you have d omega. D omega, remember what we did? Determinant of that, right? And then you have, what did it do? Minus 1 to 1, minus 1 to 1, minus 1 to 1, right? So D, typically we write this first and this later. Yeah, let's do it that. And others can also be automatically can be done. For B also you can write the same way, right? B by F, B will be equal to minus 1 to 1, minus 1 to 1, and then what do you have? You have here the N matrix, right? So N itself you find out in terms of xi eta, which is you already have in terms of xi eta. So transpose of that, and then B you also have to convert in terms of xi eta now. right? You should, is from x y system you have to convert into this system. How you do it? You do it because x is equal to summation I equal to 1 to 4, and what do you do? Ni xi eta multiplied by x xi, right? This is how to do, right? Y, this x as a function of xi eta, y as a function of xi eta. Summation I equal to 1 to 4 Ni xi eta and yi. So you put this value, replace any xy inside the body force with this, and you will get B matrix, this Bx By in terms of xi eta. Once you have that, then the rest is this one. Yeah. And for boundary integration, no need to convert, as you know, you can just do it here only, right? This is just the linear integration here. You know the length and you can do it. So same way as integral. Any question, guys? As such, chapter 9 is also, we are done only, actually. We will solve for problems, we look at the insight and all. Okay. Any questions from those who are here and from those who are online? Okay, there's no questions. See you guys tomorrow. All the best.